So let's see, an electric connection between the wiring of an electric motor and its metal frame is known as what? It's the ground. 96% of you got that correct. Again, guys, just remember when you're taking these exams, if you don't recognize it or if we haven't gone over it, it probably isn't going to be the answer. But once you start to know what these things are, you can't be going off of that testing strategy. But keep in mind, guys, the electrical connection between the wiring of an electric motor, it's just like what we talked about with the toaster. All right, that's your wonderful bread toaster. All right. Now, you have your outlet. That's right there. All right, you have your live wire that goes to the toaster. You have your neutral that goes to the toaster. And then finally, you have a ground. All right, and this ground is physically connected to the physical toaster. All right, that doesn't pass through circuitry. All right, the normal way circuitry is going and where the electrons flow is through your live and through your ground. This is like an emergency backup. All right, so if there is any chafing or any sort of electric current that passes its way through the metal toaster, that's going to go through your ground. It's the same thing. You can replace this as a motor, and it's the same thing. All right. An electrical connection between the wire and an electric motor and its metal frame is known as the ground. All right. Going through the number of cycles per second occurring in AC voltage is known as what characteristic? That is frequency. All right. Standard frequency in the US is 60 hertz. 100% of you got that correct. Good to see. All right. Frequency is the number of cycles completed in what? 1 second. All right. It's not 1 minute. That's just a straight memorization problem. True, false. A ship's electrical system works with no grounds. That is true. Where do we have one ground that is designed on the entire vessel? There is one ground. Where is it? But it's not working off of the ground.
Steering gear?
It's not steering gear. Someone in the other class said that as well. Steering gear does not have grounds. You don't want it to have grounds. Where would you have a designed ground where it's physically attached to the hull? There's only one spot on the entire vessel where it's designed to have this.
The box, the lights, right? I forgot what it's called.
Yes. So it's the box with the lights. All right. So you have your lights, right? You have one light, you have two lights, and then you have your third light. Let's just call them the fact that you have lights A, B, and C, all right, for phase A, B, and C. If A is lit, B is lit, and C is not lit, C has the ground, all right? Remember, these lights are physically attached to the hull of the ship. It's the only spot where you have a ground, all right? And the reason that it's happening is that if you had a motor, all right, with a ground where it's physically all of a sudden it's grounded on one of its phases, say it's on phase C, all right, and A, B are fine. This ground here is putting the same electricity through these two portions. All right, you now have the same wave formation and they're canceling each other out. And so C, there is no potential difference and there's no electrical current going through here. So this light is out, but now B and A have double because they're just out of phase out of each other. So they're getting double the amount of electricity. There's a potential difference and they glow twice as bright. All right. So a ship's electrical system works with no grounds. Yes, it works with no grounds because the only spot you have potential difference is between the phases. All right, where you have phase A, B, and C. All right. That's how you get a potential difference. Normal wiring has between A to the ground. This is the ground, and this is phase A. All right. We don't have that on a vessel. The only portion we have that is ground is the one that's actually attached to the light bulbs, and that's to detect grounds. All right. A single phase 2-wire AC has how many live wires? It has one. One live wire, the other one is a neutral, or it's going back to the ground. All right, this is residential. 84% of you got that correct. Good job. True, false, a ground on one phase of a three-phase, 3-wire AC system will cause damage to the ship and all electrical components. The answer is false. All right, one ground isn't the problem. It's when you have two. All right. 2 is when you're going to have actual damage to equipment, but it won't be damage to the ship. You're not going to have damage to all electrical components. It's only what's in the path. All right. Keep that in mind. It's like when we talked about with those light bulbs. If you have 3 light bulbs, you might as well just put a jumper in between those 2 portions that have the grounds. All right. And instead of having just a jumper, you have an electrical piece of equipment. You're going to have a motor that can catch fire. You're going to have transformers that can catch fire. All right. So ground indicating lamps show what? When one of the 3 lamps go out, you have a ground on that phase. 67% of you got that correct. So when all 3 are lit, you have a ground. All right. Remember, that's all 3 of them. That's normal operating condition. All right. That's normal operating condition. So that's not it. When the tester is pressed, if any lamp goes out, you have a ground on that phase. Remember, this is your testing switch. It's normally closed. All right. When the tester is pressed, if any lamp goes out, you have a ground on that phase. The tester is only to test if a light bulb is out. So if you have a condition where one light bulb, you come across it and one light bulb C is out, you press that tester, that's to ensure that you make sure that this light bulb is still functioning and you just don't have a broken light bulb. You're removing the ground. All right, so that's incorrect. When one of the 3 lights go out, you have a ground on the other 2 lamps. That is also not true. Again, for what we just stated. All right. You have your waveform. All right. And you have your ground, you're back feeding electricity from phase C into itself. You have no potential difference. All right. Clear all that. And we go through to number 9. How many live wires would you need to make a residential 240 outlet? You would need 2 of them. Again, a residential box looks like this. All right. You have 120. You have a ground or your neutral. And then you have your 120 again. All right. To make 240, you need to take one off of the 120 and you take another one. And then you have your ground. All right. 240 outlets look like this. They have sideways and you have 2 120s. And this is your actual ground. All right, that's how you get 240. And then true, false, AC voltage reverses polarity. That's true. It's constantly flipping. All right, you're basically taking the same electrons and you're just shifting them back and forth. Any questions on today's quiz that I didn't cover? No? Okay. So let us continue into, that's the wrong schedule. There we go. New share. So today is the 6th, and let's discuss the rest of the semester. All right, we don't have a lot of time left. What is that? So today's the 6th. Today we are going to be finishing electricity. All right. And we had quiz 3. The 13th is going to be test 3. All right. right? Now, Wednesday, the 8th, we're going to start STEAM. And we're going to have a little bit of review. There's going to be no quiz. All right. The 15th, we are going to finish STEAM. And we are more than likely going to have a quiz. It depends on how much we get through on the 8th. So I'll let you know.
I have a question.
Yes.
So if you're having the quiz on STEAM on the 15th, and then on that Monday, the 13th, we have test 3. So are we only doing like half a unit of STEAM on test 3?
So test 3 is only going to cover electricity and hydraulics. Okay. The final we'll discuss on the 8th. So it'll give you 2 weeks. All right, a prep time of what you know you have to need. And the final is scheduled for the 23rd from 8:30 to 12. And it's wherever you have a computer. You don't have to worry about the room this time.
Professor,
What's up?
will we get the quizzes? Will you post like the quizzes and the answers for us to study for the test 3 and final?
All the quizzes and everything that you should be able to. I sent out an email of how to view the quiz answers. You should.
Oh, okay.
So basically, half an hour after the quiz, you should be able to look at the answers. What
Okay.
you got wrong, all the choices, and everything like that. All right. All you have to do is view your attempt, and then when you're in view attempt, you just click on your grade. It looks like a little blue URL. All right.
Okay.
So that should be it. All right. Like I said, Wednesday is going to be discussing what the final is. It's going to be starting STEAM. We're going to do a little bit of review, maybe like 15, 20 minutes. All right. Again, guys, I want to reiterate. We have also the 7th, 9th, 14th, and 16th. I still have office hours. All right. They're all day long. And if they don't work, email me and I will help you out outside of the office hours as well. All right.
So is the final still going to be cumulative for the entire course? Or?
We're going to discuss what it is on Wednesday. I have to run some numbers of what I'm going to be doing. All right. And also I have to play around with how I'm going to be doing test 3. All right. Because as of right now, I haven't figured out a way to put pictures on the quizzes or on the examinations. All right.
Is it going to be 50 questions?
Again, we'll discuss that all. It's probably more likely going to be 100 for the final.
No, for the test 3.
Oh, yeah, 50 questions. Thank you. All right. And again, just electricity and hydraulics. All right.
It is going to be similar with the quizzes, right?
Yeah, it's going to look exactly the same as what we've been doing with the quizzes. So I will discuss that more on Wednesday. But like I said, open notes, open PowerPoint. But with that, don't be coming to me and saying that you didn't have the Blackboard wasn't downloading your PowerPoints. You should be able to download them, have them up on your computer, print them out if you like that better. All right. You just can't have videos up and you can't have outside help. Any other questions on what we got going on? How many people have finals? How many people had finals canceled? Anybody know yet or no?
I had a final right before this.
You had a final right before this.
Yeah. So he
Okay.
advanced time.
That's interesting.
I have I have one funnel that's optional right now. They just changed it for Professor Bulgarian. I don't know if you know what happened to him.
I know he passed away.
Yeah. So they just made it optional. We have one more test to do, and then they're going to make it optional depending on your average for the test.
Okay. Yeah, the email came out this morning. Alrighty then. Let's clear all this. And let's continue with today. So, new share, Microsoft Whiteboard. Alrighty then. So a couple questions that were talked about at the end of last class was how to chase grounds and how to check grounds. All right, so chasing grounds, like we talked about. Sharing is paused. Come on. Are you guys seeing the whiteboard? Yes?
Yep.
Okay, cool. So if you have a ground on phase C, this is your main main bus. All right. So A and B, you just walk by the switchboard. A and B are lit. You test it. C is not lit. The light bulb is not out. And we're just saying it's going to be the lighting circuit we're going to worry about. Don't think too much into it. All right. So how would we go through? And these are transformers. How would we chase this ground? How do we go and find it in a system? We're not going to be able to find it down to the exact light bulb, but we can get to a room. How do we go about doing that? What would we start off with? How would we know it's on phase C, but phase C goes everywhere on the vessel. How would we try and find it just to a singular room? Anybody have any ideas? What do we have before we go into a breaker box? This is a breaker box, right? And these are live wires coming in. We have phase B and we have phase C. What do we have before it even enters our breaker box? What gives us the ability of control? All right, we're engineers. We like to have options. We like to be able to control certain things. Switches, buttons, things like that.
Is it just the amount of current that you let through? So I mean, that's what a circuit breaker does. When there's too much going through, it just pops, right? So
Well, you're not going to be. It's not, if you have a ground, it's not going to pop the circuit breaker unless it's a really bad ground. All right,
Okay.
you might have like a small one. All right, so how would we go chase it? What if it's not going to pop a circuit breaker? Remember, these lines are not just going to feed one little circuit breaker box. All right, and one breaker box is not going to house just one lighting circuit. So what do we need? What's going to be on the outside of all of these boxes? Every one of these boxes will have their own what? every single one is going to have their own main breaker. All right. So every single circuit breaker box is going to have a main breaker going into that circuit breaker box. All right. So that way you can control power into the breaker panel if you need to work on any of the individual breakers. All right. But the other function of it is to chase your ground. So if you have multiple lighting panels, you would go through and have somebody standing at your lighting, basically right on these lights. And you would go through and you would open up this breaker to this entire panel. And once this light goes on, and after you've went through and you have phase C, and phase C has all of these different breakers, and you might have breaker panel 1, you might have breaker panel 2, 3, and so on. And when you get to 3, after switching 1 off and the light doesn't go off, and then you turn it back on, all right, then you go to breaker panel 2. You switch it off, and if the light doesn't come back on, you know that the ground isn't in 2. And you finally get to 3, you switch off the breaker box, and the light goes back on. You now know that your ground is on C because it's on phase C, and then you're on 3 for breaker box 3. All right. And like I said, if this is breaker box 3 and you have multiple breakers inside of it, now you're in your panel. And you keep flipping breakers until you figure out which one it is. And that's how you just step yourself down. You start off with a huge amount and you work until you get to a smaller and smaller piece. All right. It's like a filtration system. All right. You don't start with a very, very fine filter because then that will collect everything and it will just be overwhelmed. All right. You start with a very coarse filter and you slowly step it down the more you go through it. All right. Does that make sense? Are we good on this? All right. So let's finish electricity. All right, then. So let's continue on. We went through all of this. So let's go through electrical distributions and kind of diagrams. All right. So this is what you're going to see when you go out to C. You're going to have, this is what a normal distribution electrical panel will look like. All right. This isn't going to be laminated and put on your main bus, but if you are on a higher tech vessel, you can have what's going to show up on your screen in a second on your computer screen there, or you can have just general schematics. Every ship is going to have their own schematics. All right. So always on the top, you're going to have your main switchboard. All right. Your MSB. This is a 450 volt section. All right. And now we have basically individual breakers that come off of them. All right. They go down and they're feeding what's called a motor controller. All right. Motor controllers have a couple of different pieces to them. They are for isolation. They start and stop. speed control, reversing, and like an overload protection. All right. So for isolation, what are we isolating? From what to what? Let's start with the first thing. What are we isolating from? What could be the isolation?
Like other motors you have coming off the line, or any other lines you have coming off the 450 section.
Yes. So you're isolating from your main switchboard to your motor controller. Okay? Utilizing this breaker right here. If you would have to work inside of this motor controller, then that would be isolation. But what about your start and stop? If you have a start and stop button and there's a short in it, do you want 440 or 450 volt going through it? And you can get electrocuted by just pressing that start button? That would hurt. A lot. So thinking of isolation, what else can we isolate? And how would we isolate it? Well, we can isolate our start and stop buttons, our reset, our speed controller, our reverse option if we have one. But how would we isolate them? What would we do? Would we have a push button that has a nice long stick inside of it to isolate you from the actual start button? Would that be it? And we still have 440 going through? Is that what we're doing? How do we isolate our start button? From the high voltage to protect our users, our operators, from you. How do you protect yourself with these motor controllers?
Resistors?
You're not going to have resistors, but what are you going to do to protect yourself? What do you not want? You don't want 440 volt, right? So what can you do to bring it down? What do we do for lighting?
Would you use a relay?
You could use a relay. All right. Some instances will use a relay, and that's very correct. But what do relays do? Relays are actually little tiny motor controllers, basically. They serve the same functions. But what is a relay doing in like a car? All right. The big thing that what we want to do is we want to use the electricity that's coming in. All right. And we have the electricity that comes in and we put it through a step down transformer. All right. And this is just for our control circuit. All right. So we'll have a 12 volt control circuit, but we're also going to have our main lines coming in right next to it. All right. And the 12 volt circuit is going to have all your start, your stop, and your reset. All right. And all of this 12 volt circuit is going to control basically a breaker and that breaker is going to start or stop your motor. All right. So that's another way you can use isolation to protect yourself. Now, what else do we have? We have a motor control center. So we can have sub panels. All right. So we can have not just one motor controller coming off of one line off of the main switchboard, but you can have a 440 line going to another motor controller center, another sub panel that still uses 440 or 450 with separate motor controllers. All right, this could be the saltwater pump number 1. This could be saltwater pump number 2, and so on and so forth. All right. These are called branches if they go directly to a controller or to a system or to a component. If they go to a sub panel, it's called a feeder. Now, this is what our ship looks like. This is what the TSCS 6 looks like. All right, we have our main switchboard. We have our shore power that comes in through a breaker. We have our TGs. We have our diesel generator. And then we have a transformer. And this is our 120 main switchboard. All right, so over here we have our 440 or our 450 volt. And over here we have our 120 volt. We keep them separated via one transformer. All right, we don't have a transformer going to every lighting circuit. All right, so we have our 120 volt loads, lighting panels, power panels, the galley, all the outlets in your room, everything like that. All right, and then over here, we have our main switchboard that feeds all of our individual loads, anything that we would normally be utilizing for operation, our pumps, our sewage treatment plant, everything like that. All right, and then we have something over here called the ESB. Who knows what that could stand for? What does our ESB stand for? We have
Emergency switchboard.
our emergency switchboard. All right. So that's our emergency switchboard. And with that, we have all of our emergency loads, our fire pumps, our emergency lighting. Again, we have another 120, but it's our 120 for our emergency switchboard section. All right. So there's our emergency diesel generator. Now, here's the interesting thing. We have 2 breakers on one feeder line. Why is that? What is going on there? Why would we have 2? When none other, even what's coming in our main power, doesn't have 2. Why do we have 2 separating our main switchboard and our emergency switchboard? What is going on? What would we want to do? When we walk around the vessel, imagine that we're on the vessel. Did you see, and you look up and you looked at the lighting, did anybody see a little red E anywhere on board the vessel on your light?
Yes.
Okay. Those lights, were they lit? When you walked around the vessel?
Yeah.
Okay. So those were emergency lights. All right. That was coming off of your emergency lighting panel, but they were still lit and our emergency generator wasn't running. So what was going on? And that was normal operating conditions. What does that mean for these lights? What does those mean for these breakers?
The power is going to continue to run through the main circuit board until through the emergency circuit board, the power of those lights. When
Yes.
the main circuit board shuts down, it's going to break that, or it overloads. It's going to break the breakers, right? That attaches the main switchboard to the emergency switchboard.
Okay, so you were correct except for the overload. It won't overload any of your motor controls or anything like that. You're basically, what's happening, guys, is normal operating conditions, right? What we have right here. Just for right now, red means that that breaker is closed. All right, if it's grayed out, it's open. And if it's grayed, it's not running right now. All right, just for what we're going to talk about. So normal operating conditions, we're going across the Atlantic. All right, we have green power going to everything. Everything's fine and dandy. All right, all of a sudden, we lose one of our TGs. All right. And if that happens, and we can't get load to be picked up, we might possibly lose both TGs. All right, our diesel generator will come on in a few seconds later. I believe the time is 20 seconds. But the next thing that happens is that the diesel generator breaker will close and try and power the main bus. If there's a problem, all right, where if these three can't handle it, something happens, all right, that's why it's called an emergency. Something happens that it's unexpected. And we lose power to all three of those. They are not providing power to our main switchboard. All right, look at this. This one right here is closed, and this one right here is closed. We lose power. We black out. The entire ship goes dark. And this is what we have. We have a sensing line. So this breaker right here is sensing the power coming from your main switchboard. When there is a lack of power, when there is no power coming from your main switchboard, this breaker will pop open. And thus your emergency generator will start, and it will feed only your emergency generator load. All right? Because these are smaller generators. They're not made to handle the entire ship's load. You have very specific emergency loads, and that's it. But some vessels will have their emergency generator used as their harbor generator. My last ship I was on, we used it such as that. Every time we pulled into the pier, we would shut down our main generators, and we would basically just go on our emergency. So does that mean that we're walking around with only emergency loads running? Does it mean I can't take a shower because the light that's in my shower is not on the emergency bus? What do we do? What is an engineer to do in this situation? Is there any
You just
hope?
close the breaker that attaches the emergency to the main.
Yes. So this is what's called a feedback control. All right, they usually take keys to do it. All right, most chiefs will leave the key in it to do it, but it is a breaker that you will close and you will backfeed your main switchboard. All right, you have to be careful. You can overload this generator, but as long as you don't turn on too much components, it could handle your lighting section, no problem. All right. So that is kind of what's going to go happening. Now, you close that breaker. Like I said, now we have power going to everything. And then the other thing is if we get our diesel generator back online, all right, we have power. This senses power. It will break this circuit breaker. And now everything's all fine and dandy. We're good. All right. Any questions on what we just did? Come on. Everybody good on all that? So again, no quiz this Wednesday. Be prepared for to go through and hit Steam hard. All right. Take a look at your mug books again. Get that Steam motorcycle memorized. All right. Now, if anybody has excessive absences that they know they have, stick around All right, everyone else is good. If you have any concerns about your absences, now's the time to talk about it. All right, so just kind of wait until we break loose, but I'll see you guys all on Wednesday.
Do I have any absences? I just want to know.
I'm going to go through and take a look at that during the week. All right, so I'm going to basically look through and see who is get the real numbers. Like I said, I wasn't going to deal with this until the end of the semester. Okay. And we'll talk it through. Everyone will get an email if they have absences that's overloaded. All right.
Have a good day.
Professor?
Have a good one.
Good day, Professor.
Was that you, Shane?
Yes. I know I just asked about the quiz, but I tried checking again. Do you just tell me again, how do I look, check the answers and the questions just to make sure?
If you go into, all right, so let me see. Let me go into it myself. Go to modules, go to like you're going to the quiz. All
Yep.
right. It's loading for me. Now, what you're going to do is you're going to view attempt.
Does that begin or? Oh yeah, view all attempts.
Okay.
Yep.
Now you have your grade there, right?
Yeah.
Click the grade.
Oh. Oh,
Now you can
okay.
see everything?
Yep.
Okay.
Thank you very much.
You're all set.
Have a good day.
Yep. All right. Is everybody else just sitting here because of absences?
Oh, yes, sir. Ishmael.
Say again?
Yeah, Ishmael Bonds. Yeah, for the
Yes.
absences.
Yes. As you've been since the beginning, since we talked about it in the beginning,
Yes, sir.
we've been working it through with that. All right.
Okay, sir. All right, sir.
So all of your doctor's notes, you've been great at getting them to me. So you're fine with
Yes,
absences.
sir.
Okay.
All right. Thank you, sir.
Yep. Everybody else? Anybody else have any problems? All right, then I'm going to close this out.